Alright, so now we're going to move on to graphing the second function there. So here we have g of x was equal to x squared minus 4x plus 3 over x plus 1. So now here what we're going to do here is we're going to factor and see if we can come up with any, or cancel any terms out. So factoring our numerator, we have our product is 3 and our sum is negative 4. So the numbers that will work with that are negative 3 and negative 1. So g of x is equal to x squared minus 3x minus x plus 3 all over x plus 1. Grouping our first set together, we have g of x. There our common factor is x. We have x minus 3. And in our common factor, our second group, that is just negative 1. Remember, we want our brackets to look the same, so we take out negative 1, and we have x minus 3. That's over x plus 1. Taking out that other common factor from our whole set here, we have g of x is equal to x minus 3. What we're left with is x minus 1. That's all divided there by x plus 1. So if you guys look here, there is actually no common factors here. So we have x minus 3 and x minus 1. That's all over x plus 1. So there's no common factors there. So what that means there is that we're going to have an asymptote. So we'll have an asymptote instead of that point of discontinuity. And one thing here to note, because we can't cancel out any factors, and because we have this x squared term in the top, we can actually simplify this into our standard equation, or else it's really, really hard. So one thing that we, and you guys are going to see this when we actually graph it, is that it's going to create this really kind of crazy looking graph, and it's not really something we've looked at before. So one thing that we can do is we can find the vertical asymptote. So we can find the horizontal asymptote using our standard formula, or that standard equation. So one thing that we can do though is we can find our vertical asymptote. And so this one is when you just let the denominator equal to 0. So here we'll find our vertical asymptote, and I'll show you in the graphing calculator why this is such a crazy graph, okay? So here we have x plus 1 is equal to 0. Solving for x, hex, we have x is equal to negative 1, okay? So then from here, what we can do is we can create a table of values. So we have x and y. And so what we want to start off here is, let's start off with our vertical asymptote. Put that somewhere in the middle there, so we have negative 1 and undefined. We can go a few above, a few below, and it's actually going to be really important to go a little bit more than what we would normally do, because this creates such a crazy graph. And so one thing is, if you're ever graphing by hand, make sure you always double check it with your graphing calculator to make sure you did it right. Because there is one thing that if we stopped after, say, a couple points after above and below our negative 1, we're going to be like, oh, this is just totally fine. But then if we go a couple more points outside of that range, we're going to start seeing a kind of a crazy looking graph. And so let's graph a few of these points here. So we'll go with negative 2, negative 3, negative 4, and we'll do 0, 1, 2, and I'm just going to go one further. We're going to do 3. We're going to see what happens at 3. Okay? So starting off, we can go with negative 4. Putting this into, we can even put this into x minus 3, x minus 1, all divided by x plus 1. Or if you want to, you can put that into your original equation. They're both the exact same thing, so it's up to you. Alright? So here, I'm just going to put this into our simplified form. So we had negative 4 minus 3 is negative 7. Times that by negative 4 minus 1 is negative 5. I'll divide that by negative 4 plus 1, so it'd be negative 3. If you guys put that into your calculators, what you guys will find is that we have negative 11.67 approximately. Okay, moving on to x is equal to negative 3, we have negative 3 minus 3 is negative 6. times it by negative 3 minus 1 is negative 4. Divide that by negative 3 plus 1 is negative 2. And what we have is y is equal to negative 12. Going to negative 2, we have negative 2 minus 3 is negative 5. And negative 2 minus 1 is negative 3. That's all divided by negative 2 plus 1 is negative 1. And we have that is equal to negative 15 there. Okay. Moving on, we're going to put 0 in for x. We have negative 3 times negative 1. All divided by 0 plus 1 is just 1. And we have that y is equal to 3. When x is equal to 1, we have 1 minus 3 is negative 2. 1 minus 1 is 0. And 1 plus 1 is 2. That is simply equal to 0 there. Then going on to x is equal to 2, we have 2 minus 3 is negative 1. 2 minus 1 is 1. And 2 plus 1 is 3. So that is equal to negative 1 over 3, or if we want to go into decimals, it'd be negative 0.33. And then our last one there, which we're going to see a bit of a crazy thing going on, is that we have 3 minus 3 is 0. Times 3 minus 1 is 2. Divide that by 3 plus 1 is 4. This one, if you notice, this one here is equal to 0. So here is kind of going into that nice pattern that we've been seeing, and then all of a sudden this here just decides to screw things up. And what we're going to see is if we keep on going, it's going to continue to get screwed up. And so it doesn't follow that nice pattern. So one thing that we're going to jump to our graphing calculator, and we're going to actually see what this looks like just before we start graphing, just so I can kind of show you what on earth is happening to this graph, okay? So please, if you haven't already graphed it into your graphing calculator, pause the video and put this in and see what kind of crazy graph we get this. And it's not super crazy, but it just kind of behaves a little bit differently than what we would normally see, okay? So here we have, this is the graph of y is equal to x squared minus 4x plus 3. Divide that by x plus 1. So if you notice, it kind of creates this like really strange boomerang sort of looking graph. They're very strange, but this is actually, this is I guess a good way to show that how it behaves differently just by changing one factor. So there we had a negative 4x instead of a positive. So it creates this really kind of crazy looking graph, and this will help you to see that normally what we'd see is that you know, the function would go down and down and down, and it would keep going down, but it would kind of level off and until it got close to that horizontal asymptote. And so this one's a little bit, we can't see that, so this one has like this crazy, if you could even call those horizontal asymptotes, but this hopefully helps prove that point that when we have an x squared term in the numerator and we can't cancel it out or simplify it, it creates this really crazy graph where we can actually find the horizontal asymptote. So try your best. You guys do have your graphing calculators, so you guys can use those to help you see this. So yeah, from here, let's actually graph this crazy looking thing, okay? Alright, so if you haven't already done so, let's start graphing our second function there. So let's start by spacing out or labeling our spacing. And I'm going to go by every 2 tick marks will be 3 for a y-axis, just because we have some negative 11.6 values, so I want to make sure I show those. Alright, so from there we had x is equal to negative 4 and negative 11.6. That's going to be pretty much touching that y is equal to negative 12 line there. Then we had negative 3 and negative 12. So once again, it's not really going to be much of a change there. Then we had x is equal to -2 and y is equal to -15. And if you guys want to just help see that shape of the graph, you guys could even graph a few more points there. So try x is equal to -5, which is y is equal to -12. So start getting our crazy looking graph, drawing that out there. And one thing to note is that this graph here, if you guys remember, this one here, it'll start to approach our asymptote of y is equal to x is equal to -1. So it'll be approaching this asymptote, but then this one here will kind of curve on in and do its crazy little thing there, alright? Then moving on to the right side of our asymptote, we have 0 and 3. We have 1 and 0. And then 2 and -1/3. And 3 and 0. So from there again, so we'll create that crazy looking graph. So if I'm going to go towards that asymptote, it's going to get really close. It'll approach it, but we'll never actually cross it. And then going from left to right from 3 on, it's going to start moving back on up. Maybe some sort of crazy graph looking like this. And last thing there is we need to label this. So we have y is equal to x squared minus 4x plus 3 over x plus 1. Alright, so here you can see that just by changing our 4x from negative to or positive to negative, it creates this like really crazy graph. It changes it totally, alright? So now let's just answer that last little part of the question there. So let's explain maybe any differences or similarities. So I'm going to clear this writing over down at the bottom, so hopefully you guys should still have some more room. Alright, so here let's talk about, let's talk about one similarity. And we're not going to get into the nitty-gritty details and pick out little itty-bitty details that are different. We're just going to talk about maybe some of the things in general. And so one thing that I just want to talk about that there is technically a similarity is that there is a non-permissible value, both of them. So f of x and g of x both have non-permissible values. And that is at x is equal to -1. So remember, the non-permissible values, that could be in general, so that includes your point of discontinuity and your asymptotes. So I'm going to scroll on up here. So here we see that here, although one has a hole, one has an asymptote, they still have that same non-permissible value. So in general, their non-permissible value is at x is equal to -1, okay? So they both don't have values there. But then this is where we could be getting into our differences a little bit, okay? So our differences. And if there's any other similarities you guys want to point out, go for it, but I'm just going to do, I don't want to go into huge detail, let's just talk about the generalized kind of similarities and differences. So as you notice with, let's talk about f of x first. So f of x, it does have a non-permissible value at x is equal to -1, but f of x has a hole at x is equal to -1. So that's comparing it to g of x, which has that asymptote, okay? And then if you guys even want to talk about maybe more along the lines of a shape, so f of x is also linear, where g of x is not. Okay? So we can label this 1 and 2. So then g of x, this one has an asymptote. And that one is at x is equal to -1. And it's non-linear. I'm not going to get into the naming of different graphs. It's not quadratic. And so we can just say that this one is non-linear. Okay? Alright. So now we're getting close to that 50-minute mark there. Anyways, we are done the questions. If you guys want some more details, come and talk to me. Otherwise, you guys can get started on your homework.